Let's do math. So we're at 10.4, 10.3. 10.3, check on learning. So here we go. It says use a graph to solve the equation log base 2 of that equals that, the nearest integer. So here's the issue though. We don't have a way to enter that into our calculator. In most calculators, I should say. So first we're going to change that to log base 10, and then we can put that into our calculator. So log base 2 of 3x minus 4 is equal to log base 10 of 3x minus 4 over log of 2, and so that is something that we can enter into our calculator. So we're going to enter basically y equals that, and a y equals 4.5, and we're going to see what happens. So here we go. Go to our y equals button. So y equals 4.5, that's the bottom one. So then we're going to use our log base 10, 3x minus 4 divided by log base 10 of 2. So there is a, let's zoom in. So we do have a point of intersection right there. Again, we can either eyeball it or make the calculator work for me. So we're going to find the intersection, blue curve, red curve. Intersection is at x equals 8.876. 8.876. So then our problem says to the nearest integer, so that's whole number, so we're going to round 8 up to 9, which is our answer. Next. Solve the logarithmic equation algebraically. Okay, so I'm looking at it. They are both log base 10. We can combine those. So let's go ahead and do that. So that's going to be log base 10 of x times x plus 3 equals 1. So that means that 10 to the power of 1 is equal to x squared plus 3x. I probably should have left it factored. We'll leave it factored. x plus 3. So that's from our definition of log. Remember, it's log base 10 of the other guy. So now we just algebra and we're good to go, right? Oh, I did want to distribute it out because I'm going to subtract 10 from both sides. So we're going to have 0 equals x squared plus 3x minus 10. So when we factor this, I'm assuming it's a 2 and a 5. We're going to have plus 5 minus 2. So when we add them together, we're going to get a positive 3x equals 0. So then we've got x equals negative 5 and 2. So, enter the correct value in the box. We're going to say -5 and 2. Why wouldn't it be -5? So let's plug it back in and see what happens. So let's plug both of these values back in and see what happens. So if we throw, here's our top one right here. So if we throw -5 in, I'm going to look at our graphs real quick. So I'm just going to graph this real quick, see what happens. Because I assume that there's probably an asymptote somewhere. Oh, yeah, of course. So I'm forgetting about all of my logarithm characteristics, right? So the fact there's multiplication here is going to be like a horizontal stretch or compression, but a +3 is going to move it to the left 3. And so then we'll have an asymptote at -3. And then we'll never have that. We'll never have a -5. So if we were to graph it, like I was going to do, it would be log of x plus 3 window. I need that x minimum to go down to -5. Yeah, so see how it breaks here, and there would be an asymptote here. So -5 is out. So I remember the book saying at one point, make sure you always double check and replug your answers in. That's why. So the answer for this one is just 2. Good job. I learned something from that one. Solve the logarithmic equation algebraically. So we're going to do the same thing, except this time, oh look, we have log base 8, log base 8. We have a property that tells us we can just say 7x minus 5 is equal to 4x plus 9. Well, that's some easy algebra right there. So we're going to subtract 4x from both sides. We're going to add 5 to both sides. So then we're going to have 7, 6, 5, 4, 3. 3x equals, I can add 14, or x equals 14 over 3, which is equal to, what is that, 2, 3, 14 divided by 3. Is that a happy decimal? No, it's not a happy decimal. So let's see what form they want this answer in. Just leave it in 14 over 3. Typically you would simplify it into like 4 and however many left over, but that's not what they want, so we'll stick with that. Last but not least, so an equation for loudness of a sound in decibels is L equals 10 log of R, where R is the relative intensity of the sound. The loudness at a music concert is 115 decibels. What is the relative intensity for the sound? So let's plug everything we know in, and then we'll solve from there. So we know that 115 decibels equals 10 log of R, and R is the relative intensity of the sound, so we need to solve for R. So, first things first, we'll divide both sides by 10. That means we got that equals log base 10 of R. So by definition of log, we can say 10 to the 11.5 power equals R. Make sure we're on the right track. 11.5. So I'm going to plug this in just in case I need it later on. So a regular conversation is found to have 62 decibels. What is the relative intensity of this sound? Enter the correct value in the box. I was hoping there'd be an easier way for me to do it. But am I going to have to do this a bunch of times? No, just twice. Okay, so a regular conversation is found to have 62 decibels. So we'll do that in blue. So that's going to be 62 equals 10 log of R. So 6.2 divide both sides by 10 log of R. So it's going to be 10 to the power of 6.2 equals R. 6.2. I was just checking to see if it told me that I needed to round anything. I didn't think it did, but whatever. 6.2. How many times greater is the intensity of the concert than the conversation? So this is where we're going to take a fraction or a ratio. That was the word I was looking for. So how much times greater is the intensity of the concert? So we want the bigger number over the smaller number. So we're going to take this number over that number. So we're going to have 10, 11.5 divided by 10, 6.2. And hopefully you should not need a calculator for this part just yet, because you can take 11.5 minus 6.2 and you will have 10 to the power of 5.3, and that you can stick into your calculator. So equals 199,526 times louder. That seems like a lot. Concerts are really loud. Let's check that answer. Look at that. Oh, they rounded. Round to the nearest 100. Yeah, it did tell us to round. So you would type in 199. So there you go. Not too difficult, I hope. Hopefully it all makes sense. If not, I'll see you in class and we'll practice some more.